The first type of reaction that we'll go over today is a combustion reaction. In this type of reaction, a hydrocarbon, which is an organic compound made up of hydrogen and carbon, bonds with oxygen, creating carbon dioxide and water, which takes the form of water vapor. This type of reaction is always exothermic, meaning that it gives off heat. In this case, the hydrocarbon is methane, and the oxygen comes from the air. This reaction is represented by the equation 1 methane molecule plus 2 oxygen molecules yields 1 carbon dioxide molecule and 2 water molecules. Next, we'll review a decomposition reaction. In this type, a complex compound breaks down into 2 or more simpler compounds or elements. Usually this is a solid or liquid decomposing into a gas, so it can be hard to see. What you are seeing is the decomposition of hydrogen peroxide into hydrogen gas and oxygen gas, which is modeled by the equation 1 molecule of hydrogen peroxide yields 1 molecule of hydrogen and 1 molecule of oxygen. However, in this demonstration, dish soap is added, which allows the gas to form bubbles, and potassium iodide is added as a catalyst, meaning it dramatically increases the rate at which the reaction occurs without altering the nature of the reaction itself. Our third reaction type is a synthesis reaction. This is the polar opposite of a decomposition reaction, as 2 simple compounds or elements combine to form a more complex compound. What you are seeing is the synthesis of magnesium with oxygen, forming magnesium oxide. This is modeled by the equation 2 atoms of magnesium plus 1 molecule of oxygen yields 2 formula units of magnesium oxide. This reaction can occur at room temperature, but when sufficiently heated, it occurs rapidly, giving off a bright white flame. Next up is the single replacement reaction. In this reaction type, when 2 compounds are exposed to each other, an element from one compound trades places with an element from the other compound. In this case, a section of copper is placed into a solution of silver nitrate. The copper takes the place of the silver, leaving elemental silver and a copper nitrate solution. This is modeled by the equation 1 atom of copper plus 2 formula units of silver nitrate yields 1 formula unit of copper nitrate and 2 atoms of silver. The final type of chemical reaction is the double replacement reaction. In these reactions, the anion and cation of 2 different molecules switch places, forming 2 entirely new compounds. In this case, acetic acid is poured into a beaker containing bicarbonate of soda. You know these compounds as vinegar and baking soda, respectively. When these compounds come into contact with each other, the reaction forms sodium acetate and carbonic acid. This is modeled by the equation 1 molecule of acetic acid plus 1 molecule of bicarbonate of soda yields 1 molecule of sodium acetate and 1 molecule of carbonic acid. The impressive visuals involved don't actually come from this reaction, however. The carbonic acid rapidly goes through a decomposition reaction, creating water and carbon dioxide. The froth is actually air bubbles filled with the CO2 from this secondary reaction.